Welcome Algebra 1, this is 10.5, graphing square root functions. The essential question is, what are the key points when graphing a square root function? Let's begin. So here's a graph of a square root function and what it looks like. It's this curve right here. This is actually the graph of y equals the square root of x. So all square root functions are actually square rooting the x variable. Some things to note about this. We have a few key parts graphed right here. You have this curved shape. And this y equals square root of x, this is actually the parent function, which is, if you remember, it's the simplest form. Some other things to note. It kind of looks like half of a sideways parabola. So parabola y equals square root of y equals x squared. It's a sideways parabola. It could be, if you drew another half of it like this, you kind of see that parabola shape going to the right. So it's only half of that though. Can't have both halves. It also has a starting point. So this point right here, 0, 0, that is the starting point for the square root function. It's kind of like that vertex of the sideways parabola, if we drew that out. And also note that one end keeps going on forever. So this point keeps going up, this line goes up and to the right forever, and forms this curved shape. Other things to note, what's the domain and range? Well, if I asked you to find the domain, you have to use this starting point. So the starting point is going to be our key point of graphing a square root function. And the starting point is at 0, 0. So our domain, which is all the x values, you're looking at this graph, your x value, the smallest value is 0, and then it's all x values above that. So it's 0, 1, 2, 3, and everything in between. And it'll keep going to the right forever. So it's all x values that are greater than or equal to 0. So everything that's 0 or positive for x. So your range is the y values. Use that starting point again. Your y starts at 0 and it keeps going up. It's going up to 1 right here and 2 right here and 3 right here. And it just keeps going up and to the right. So it kind of goes up slower. So your range is y is greater than or equal to 0. All right. What about if we wanted to figure out domain and range algebraically? So I didn't actually have the graph graphed. I'm just using the equation, y equals square root of x. The domain. One thing to note to find the domain, you can't square root a negative number, so I can't do square root of like -1. That doesn't come out to a real answer. There's no real solution for that. So your starting point is actually where you square root 0. So where you get 0 inside the square root. So in this case, square root of x, that's where x equals 0, because if you plug in a 0 for x, you get the square root of 0. So that's your starting point for the domain. So my domain, which again is all my x values, is x is going to be bigger, greater than or equal to 0, because if you plugged in bigger values for x, those would exist. If I plugged in negative values for x, like if I tried to plug in -1 or -2, those you can't square root a negative number. So it has to be all x values that are bigger than 0 and 0. The range. So you got to ask yourself when you start plugging things in, is y getting larger or smaller? Again, you're starting where the starting point where x is equal to 0. If you plug that in, where you're square rooting 0. So y equals the square root of 0. So y is going to equal 0. And x is getting, as x gets bigger, y gets bigger. So it's going to be y is greater than or equal to 0. And that's the same thing we saw with the graphs before. Now let's do this one. I want to find the domain and range of this square root function. So it's not the parent anymore. It's got a few more numbers on this. To find the domain, I got to figure out where you're square rooting. That thing inside the square root, the radicand, is going to x is going to equal 0. So 3x minus 9 equals 0. I want to solve for x. So I'm going to add 9 to both sides. And then you're going to get 3x equals 9. And then I want to divide by 3 on both sides. So you're going to get x equal to 3. So x of 3 is kind of like my starting point when x is 3. And so my domain is going to be 3x is going to be greater than 3 or equal to 3. And that is going to be my domain. Now to find the range. So if 3 is the starting point for x, what's y going to be in that case? Well, I'm going to substitute that in. So I'm going to get y equals 2 times the square root of, well, 3 times 3 minus 9, which is going to be 2 times the square root of 9 minus 9, which is 2 times the square root of 0, or 2 times 0, so that's also 0. So your y values are going to be all greater than or equal to 0. That's the domain and range. Now let's try to actually graph a square root function. So I'm going to graph y equals square root of x plus 2. First thing, you want to find the starting point. And again, that's where you're square rooting 0. So in this case, it's square root of x here. That's where your radicand is going to be 0. So if square root of x, we want to make that equal 0. So that means x is going to have to equal 0. So my starting point is where x equals 0. And when x is 0, what's my y going to be? I'm actually going to just start plotting that in this table down here. So in x of 0, if you plug in 0 for x, you get square root of 0 plus 2, which is going to equal 2. So your starting point is 0, 2. I'm going to plot that 0 and 2 up. Now we want to plot a few more points. So I'm going to actually label that as well. 0, 2. And I want to plot a few more points. So I can pick, let's say, if x is equal to 1. If x is 1, then you're going to get square root of 1 plus 2, which square root of 1 is just 1 plus 2, which is going to be 3. So my y is going to be 3. I'm going to plot that point 1, 3. All right, I want to do a few more points. Now you can start just going counting up 2, 3, and 4, and you might need a calculator to do some of those. One neat thing is if you know perfect squares, you can kind of pick different values for x. So in this case, at square root of x, I know some perfect squares for that square root would be, well, 1's a perfect square, 4 is, 9 and 16. So I'm going to pick x equals 4 because I already did 1. When x equals 4, you do square root of 4 plus 2, which is square root of 4 is 2 plus 2, which is going to be 4. So when x is 4, y is 4. So points right there, and I got 4, 4. So I've got enough points, but I can do one more just for fun. I can do x is 9, and this will be square root of 9 plus 2, which will be 3 plus 2, which will be 5. So when x is 9, y is 5. And 9, 5. So I've got enough points, I can do my nice curve. So again, this is your starting point. So the curve should look like that. That's pretty good. So that's my graph of the square root function. Some other things to note. Translations. We've translated other graphs before. So that graph of y equals square root of x plus 2, that was actually shifted 2 units up. It was a vertical translation up 2 units. Because when you're doing that y equals the square root of x, that plus 2, just like when we did parabolas, the plus 2 or minus 2, that plus 2 will shift it up 2 units. And for the graph down here, this is a horizontal translation. You got y equals the square root of x plus 3. That plus 3 in there, this part, since it's inside with the x in the square root sign, that's actually going to shift it left 3 units. Because it was always like the opposite of this number, if you remember, for parabolas. All right, let's do some examples. Pause the video. All right, finding the domain and range. So for your domain, I want to make that square root 0. So negative 2x plus 5 has got to equal 0. I'm going to solve for x. Subtract 5 on both sides. You get negative 2x equals negative 5. Last step, divide by negative 2. So you're going to get x equals positive 5 halves. Okay, so if x equals positive 5 halves, my domain is x is going to be, so here's the tricky thing. If you start doing bigger and bigger numbers for x, since that's a negative 2x, your domain is actually, your square root is going to be a negative number. So if you, in this case, your x is going to be less than or equal to 5 halves. Because that's negative. The range for this. So it's all x values. If you're plugging in x is 5 halves, it's going to be y is greater than or equal to 0. Next one. What's the graph of this? Pause the video. All right. So again, my starting point, since that's square root of x, the starting point is going to be at 0 for x. And if you plug in 0, let's do my table. Table's a lot easier to do this. 0 for x. Your y value is going to be square root of 0 minus 3. So 0 minus 3, which will be negative 3. So 0, negative 3 is my first point. And then I got to do a few more. I'm going to do my perfect squares. So 1, 4, and 9 in this case. If you're plugging in a 1, you get square root of 1 minus 3, which is 1 minus 3, which is negative 2. So 1, negative 2. And then plugging in 4, so square root of 4 minus 3, which is 2 minus 3, which is negative 1. So 2 negative 1, or, oops, not 2 negative 1, 4 negative 1. And for that last one, you're going to get square root of 9 minus 3, which is 3 minus 3, which is 0, so it'll be 9, 0. And I've got all those points plotted, so I'll do my curve with the starting point, and it should look like that. There you go. That's it.